Speed, distance, time equations typically boil down to one simple formula, and that simple formula is speed equals distance over time. And it can be reordered in any of these three different ways, and it's important to have this ability and to have this written down on your paper when you're trying to solve these questions, because it's very easy to get turned around. And some people use rate instead of speed, but I think it's really important to use speed in these equations. So as a simple example, if we had the speed is 60 miles per hour and the time is 3 hours, the distance that we could solve given this situation, well, distance equals speed times time. So I would get 60 miles per literally means fraction, like division, 60 miles per 1 hour times 3 hours. What you notice is the hours cancel here, and we end up with 180 miles as the distance. So that's how you use these formulas to solve for the missing thing. We had speed, we had time. The one thing that we were missing was distance, which is what we were solving. Now, average speed is not simply the average of two speeds. It is the total distance over the total time. And we have a simple example of that down here. So let's walk through this example. So if Bill drives 50 miles per hour for the first 25 miles and 25 miles per hour for the remaining 25 miles on his way to work, what is Bill's average speed? Well, we know the total distance is 50 miles because we're told he drove the first 25, then the remaining 25, which totals 50. So we just need the total time. The time spent on the first one, time is distance over speed, and the distance was 25 miles, and the speed was 50 miles per 1 hour. And when you're dividing by a fraction, you can multiply by reciprocal. So this is equal to 25 miles. Instead of dividing, I'm going to multiply by the reciprocal, 1 hour over 50 miles. And you notice the miles cancel. We get 25 over 50, which is 1 over 2. And we end up with 1/2 hour as the final value. So we have half an hour, and then we have 25 miles per hour for the remaining 25. Well, this is going to equal exactly 1 hour. So we end up with 1.5 hours on the bottom, which is the same as 3 over 2 hours on the bottom, and 50 on top. Now, instead of dividing by a fraction, we could multiply by a reciprocal. So we would have 50 times 2/3. And our unit on the bottom is going to be hours, and our unit on top is miles, because we're getting miles per hour. And 50 times 2 is 100, divided by 3 gives me 33.3 miles per hour as our average speed. So the average speed is a little closer to 25 miles per hour right here. And the reason is we spent more time driving at 25 miles an hour than we did at 50 miles an hour. We spent a full hour versus half an hour at 50. So our speed was going to be, on average, closer to 25 miles per hour than it was to 50 miles per hour. And that's how you solve an average speed problem. Focus on total distance over total time.